All right, good afternoon, everyone. Welcome to this month's edition of the NEUTC webinar series, the New England University Transportation Center. I'm really excited to have a great presentation today by some of our researchers from the University of Connecticut with the project titled Incorporating Large Language Models into Transportation Safety and Analytics. So just a quick overview before I hand the floor over to our researchers. I just want to give a quick overview of NEUTC and who we are. So the New England University Transportation Center, we are the Region 1 UTC. So up in New England, we were awarded this a couple of years back. We include, so here at UMass, we're the lead of this consortium. Some of our other consortium members in Massachusetts include MIT, Holyoke Community College, Bunker Hill Community College, the University of New Hampshire, Norwich University, and then last but not least, the University of Connecticut, who will be giving this presentation here today. So our mission at NEUTC is to advance transportation safety through transformational research, education, and tech transfer. And in doing that, we have four thematic focus areas that we have along our program, which is developing smart city infrastructure and connected systems, improving safety for all modes and populations, promoting automated vehicle safety, and embedding community engagement within transportation safety. So those are our four thematic focus areas. And then I'm also, before I hand the floor over, I'm happy to announce that our Year 3 RFP is imminently about to be released. So for those of you interested in participating in our projects for Year 3, that will be announced, and we'll provide a link to at least our NEUTC webpage in the chat here in just a moment. But that RFP will be open until just about early June. So look out for that if you're excited to submit another request for proposal with us. All right, so let's jump into this. So I'm going to hand the floor over. So we had two PIs working on this project, or a handful of PIs working on this project, but I'm going to hand the floor over to Dr. Kai Wang, who's going to introduce the team really quickly and then hand it over to our student presenters. Kai, the floor is all yours.
Yeah. Thank you, Francis. Hello, everyone. This is Kai Wang. I'm currently an assistant research professor and also project manager working at the Connecticut Transportation Institute. Actually, on this project, I'm one of the co-PIs. The PI is Dr. Taiwan Ding, who is actually one of the professors from the computer science. Another co-PI on the board is Dr. Tianxin Li, who is also an assistant research professor at the Connecticut Transportation Institute. The student, Jingwei Tang, is the person who are going to conduct the major presentation today, and he's the first-year student from the computer science department at the University of Connecticut. So with that, I'll turn over the presentation to Jingwei.
All right. Hi, my name is Jingwei, and I will be the major presenter today. So first, let's look at what problem we're trying to solve. As you may know, there is a database called CTCDR, Connecticut Crash Data Repository. It provides easy access for everyone to just download the crash data for their analysis purposes. But we want to take this even further. We aim to leverage large language models to make traffic data analysis accessible to everyone, not just data professionals, but to everyone who doesn't have data analysis experiences at all. So the first thing we have to consider is to lower the barrier. We want the large language model to handle the heavy part, the coding part of the data analysis, and allowing the user to just ask questions in natural languages and gain insights from traffic data from the CTCTR library. By doing this, we allow more perspectives of the traffic data into our analysis and the final report part, because different people will have different opinion on the data, and they will provide diverse insights, leading to a deeper understanding of the traffic patterns. This leads to a better final decision on the traffic report for the government agencies. And at the same time, we don't want to make this software takes a very long time for people to do data analysis on. So we provide a very fast analysis procedure that once you enter the natural languages prompt, which is your question, the data searches and analysis begins immediately and almost return the result to you in no time. So our goal here is to use large language model to understand the query by the user and generates the Panda script to analysis on the traffic data. Just so you know, Pandas is a well-known data analysis tool or package in Python. We also provide a lot of great visualization tools over the web portal because in most of times, people get better insights from a graph rather than long text. We also offers customizable data downloads. For data analysis, we want to use the data and do the analysis themselves. The major difference with this from the CTCTR data repository downloads is that the large language model will pre-filter and clean the data for the user so that when the data is downloaded by the user, they're ready to go. And the challenges is there are privacy issues with the database because there are sensitive data that are stored in the database and we want to prevent users from touching them. For example, there are police IDs, police names, victims name, victim IDs. Also, the scalability is also an issue with this database because every year the database renews itself and the database just grows bigger and bigger over the years. Eventually, there will be a point that the traditional large language model analysis on the data set won't work anymore because the data are too long for the large language model to understand what's going on. The last challenge, which is the biggest challenge, is to actually translate the natural language query into an accurate database command because the user doesn't get to see the database directly. They might not know what is the column name or the sets in the database. So when they construct the query, their query might not be accurate enough for the large language model to understand what to pull out from the database to do analysis on. So let's first provide a system overview. As you see, all the blue blocks in this page are a local process or a software I have wrote. Any orange blocks are an API call to the large language model. We are currently using a couple local deployed large language models, such as Llama 3.3. And we are also using API calls on OpenAI for faster result generation. The first part comes in with the large language model column extraction. This is the part where it helps large language model to understand what exactly the user is looking for. For example, the user wants the rank of the cities with the highest number of crashes to the lowest. Note that the city, this word, doesn't really exist in the database, and this is not how traffic professionals calls it. It is important for the large language model to know how to link users' ideas to the database. Therefore, we provide a method. We pre-filtered a couple variables, such as selected columns, which are just a list of the columns existing in the database. Then we also provide a unique value from each column for the large language model to better understand what is in the column, also with a description. However, this method has a slight problem. In those columns that has IDs and names, the unique value are huge and they are real names and IDs. We don't want that to happen. So for the ID columns, we don't provide unique values. We provide a sample of the values for the large language model to understand the columns data. And since user will usually enter an ambiguous prompt, for example, rank the cities with the highest number of crashes to the lowest. With this one, the user hasn't mentioned the crash severity or what kind of vehicle they're looking for, the keyword might mismatch with the database structure. So the first large language model API call's job is to match user needs to the database, which is a refine of user's prompt, the intention. Once the first large language model is done with its job, refining the user's prompt, we begin the code generation. So first, there are majorly three package we have linked in our program with large language models. The first one is pandas. Pandas is the major one. It does most of the data analysis work. The reason we want to use pandas, not like NumPy or a custom function we wrote, is that pandas is well known, and the API call to all the functions and tools within the pandas are pretty well trained with large language models. This saves us time from fine-tuning our own large language model for this prototype. And for matplotlib, it's also a well-known package for graphing. We have also considered Seaborn, which is a more advanced version of the graphing. However, the Seaborn doesn't perform as well as the matplotlib to some lower cost large language models. Besides those two, we also have custom modules, such as a heat map. A heat map generation function is implemented in the code so the user can generate an interactive map with heat map for them to play around and look at the dynamic traffic insights. So this architecture addresses the database scalability. How? First of all, the traditional way of doing this is to pass all the data to large language model. That string can be infinitely long. However, what we are passing is the database schema, how the database looks like, what are the columns, what are the unique values in the columns. That way, the data we're passing to a large language model will likely not grow too much, or it might not grow at all for some columns, such as severity, right? There are only 3 types of severity. And moreover, the custom module, we provide a custom module portal, which is like the heat map. We allow custom functions to join the large language model's API call. So we can provide enhanced functional scalability. Any custom function you want, we could technically implement in there and let the large language model call on the API for it. By doing this, developers such as me can extend capabilities by building new visualizations or analysis functions and exposing them via API to the large language model, allowing large language models to leverage these tools seamlessly. Besides those, privacy is a big concern with us. So to better provide user privacy, we have a separate mechanism in there that is hard-coded, never touched by a large language model, only by the developer. There are 3 actions after we detect code is violating our law. So how we do it is that we use code pattern matching to detect sensitive queries, such as an export of the victim's IDs. We don't allow this. So there are a lot of patterns that are hard-coded into the code security verifier, or you should say, we should say code pattern matcher. Once the system detects a pattern is fine, it will terminate the execution of the code, basically not execute the code at all. It will log the event about which cookie or who used the web browser to access this command, and also flag the requesting user for review. The reason for the third step to be there is that we want to see if there's a specific user that are trying to attack our database to grab out the personal identifiable information. And this database not only defining rules for detecting sensitive code patterns, it also includes exceptions to prevent false positives. For example, if a user wants to know how many non-severe crashes are handled by each police on each month. In this case, we do need to know the police ID to know how many police are there. However, the retrieval of the police ID and demonstrate them to the user are totally unnecessary. When we detect this pattern, that it is only doing analysis on the sensitive data, we allow it. We just don't allow showing the sensitive data to the user. The whole pattern matcher is designed to be self-evolved. The developer can regularly check the event logger to refine and update both inclusion and exclusion rules, ensuring accurate and reliable security checks over time. Because there are some logs that are being raised that are false positives, that there are also some that are false negatives. Once we allocate this, the code pattern matcher, by the time it will grow better and better and be more complete, making sure the privacy of the users are more secured. After the code generation is done, then is the fun part. We will execute the code and start the actual web rendering. So we render both datas and plots directly onto a web portal, since HTML is still one of the most famous way for people to access the network. We provide instant visualization. Once a plot is generated, we push it onto the web immediately. We also reached our promises for the custom data downloads by using a package called Streamlit. We also provide a seamless interaction since the only input from the user are the question they're trying to ask. There's totally no code required. Even you put code in there, system will not ask you on your code anyways. It will try to understand your code and try to match it with our database. And here's a short demo. The first demo we have is trying to get a list of all the crashes by their city name and rank them from biggest to smallest. At the same time, the system is smart enough to know that in this case, a heat map is a great fit to user's request. Therefore, it will generate a heat map. It automatically grabs all the GPS locations, GPS coordinates of the cities and map the data onto the city, then render this graph for us. User can pull on the map and look around. At the same time, it also provides the actual data it was graphing on in the correct rank user requested. As you see, there is a download button for them to click. Once you click the download button, you can just take the CSV file anywhere you want on your desktop. The next example we have is to rank the crashes in injury severity in a specific town name called New Haven. In this case, there are only three rows being returned since there are only three different types of injury severity log. And the next case is more interesting. We told the system, I want some sample of the driver license in the crashes, simulating an attack. By doing this, in the backend, the code is trying to access directly on driver's license and retrieving them to the front end, which is totally a violation of our rules. So in this case, the code won't be executed at all. And we will say no PI information lookup is permitted and the search is terminated. More than this, we are also able to graph any regular graph that Matplotlib supports. Once you show your intention of graphing in the query, we will start graphing them for you. The first example is a default graphing. We just say we want to graph the number of crashes in the top 5 towns with the most crashes. And the model graphes us a bar graph in blue. But what if I want a different graph, a line graph? I can just tell it in line graph. Then the model will generate us a line graph. However, the color might not be my favorite. Now this time, let's generate a bar graph, but in red bars. How about that? And there you go, a bar graph in red bars. You can customize this to anything you want. Like, do your imagination, do any data analysis you want, and we can return the result seamlessly. Now, there are some future works to be done. So first of all, we want to fine-tune a large language model with traffic-specific data, enhancing the precision and the contextual understanding of the code generation by training the large language model on real-world traffic data, of course, with privacy reserved. And secondly, you see the web page I've shown you, that prototype, is kind of plain. So we will create a real-time dashboard rendering that shows a dynamic web dashboard that displays trending user queries and visualizations in real time. For example, there might be a time that everyone care about how many crashes are in New Haven. Then before the user even need to enter the query, the data they want will already be shown in the dashboard and ready to be downloaded. Next one is automated pattern database configuration. As I said, the pattern matching database will self-evolve over time by a developer. But how about let's handle that job to large language model as well? We can enable large language model to analyze the log file and automatically update security rules for improvement of the privacy protection and decrease the number of false positives. Even more, we want to integrate some advanced data analysis tools, uh, expanding the system capabilities by incorporating more analytical libraries, such as a new model from OpenAI. It provides image to text, which means we can eventually take a user's drawing, asking what kind of graph they want and what are the synthetic data are in it, and we can generate that graph for them from a real traffic data. That's it.
Awesome, Jinwei. That was a fantastic presentation. Really, really great work going on at the University of Connecticut. This is really, really great to see. So for those of you who has any questions, there is the Q&A feature. I meant to mention that at the beginning, at the bottom of your screen. So if you have any questions for the researchers, feel free to populate that with your questions. We do have a quick one in here, actually, that somebody posted. What LLM did you use as your foundation model? Did you make a custom GPT with OpenAI, or how did you go about that to run this?
Yes. So there are several experiments we run. So the first thing we started with was Llama 3.1. With Llama 3.1, we noticed that it is trying to make API calls to pandas with some very old functions that are deceptive. And for OpenAI, we noticed that the 4.0 mini is actually a great fit for our purposes. The 4.0 mini provides enough power to generate the code for our purposes. And also at the same time, the new model, Llama 3.3, are also capable of doing this job locally. If you want to do it locally, I would say you can go with the Llama 3.3, and with the API call, you can go with the OpenAI 4.0 mini.
Awesome. We had another quick one here that I'm going to paraphrase, but so it's an LLM. So are there ways to trick them? So why not just redact the sensitive int data from the database? And this person says you can replace real IDs with alternate values. I don't know if you have any thoughts on that.
In the current database, we did replace all the real IDs and with a synthetic data. However, eventually when this get plugged into a real database, we want to also make sure that the possibility of a person attacking this mechanism and grab the personal identifiable information is zero. We want that possibility to be zero. So we developed an extra mechanism in there to stop user from trying them.
Awesome. I got another one here. How did you manage the results validation, as in make sure the results are correct? So what was your validating component here on this work?
So the validation comes in two parts. First of all, by our experiment, we have noticed the GPT-4 minis code will provide the right analysis for the user purposes, but that is not enough, of course. So we tried about 50 different prompts, and we validate the out code and their results. by looking into their code manually by human, by my eyes, I can tell that they are doing the right thing. However, they get wrong sometimes. But when they get wrong, it's very likely that it is not just purposely wrong, like functionally wrong. It also gets the syntax wrong because the user might enter a very ambiguous and complex prompt that try to trick the system. And the system eventually, by its iteration, once the code generation fails, it tries to iterate itself to fix the code with the original purpose. We noticed that if the data analysis is wrong, then the syntax of the code will very likely to be wrong as well. And in that case, we will also log the event. We didn't show it in here, but we actually log them for our development purpose.
Awesome, great. I've got another one here. And so for those folks who have asked these questions, if you have any follow-ups, feel free to post those back in. You can also comment on the answered in real time question in the Q&A prompt. So this question, so they basically said, not sure how to word it, but how are AI hallucinations eliminated or recognized? Or maybe you can speak a little bit on that.
If Francis, I think this is Kai. I can try help Jingwei to answer
Sure.
this question if I can.
Do it.
So to be honest, I'm not quite sure about what types of AI hallucination this audience has, but can you be like a little bit detailed about what types of or what specific things you want to mention? Because we basically want to just develop some AI like large language model to analyze some data in our field and basically just to focus on the research. So but if you can be a little bit specific on your question, I think we can provide you with the best answer. Just probably rephrase your question a little bit, and we can just take your answer next.
In the meantime, if that person wants to rephrase a little bit, I have another question here lined up that we can pivot to. Have you thought about using AI on reading crash diagrams? So you talked about narrative reading. What about crash diagrams? I know it's a bit of a tougher challenge without the text, but is there any thought there in terms of what could be done moving forward with some of the other crash data we have?
Yes, so it is possible for us to develop such a system effortless to analysis on the crash diagram. However, the database we plugged in doesn't contain any crash data diagram. They only contain like numbers, and for analysis purposes, for our research purposes, that is not the current focus. However, yeah, we will take that into consideration. Maybe eventually there are crash diagrams stored in our database. Then this will be a major concern that we want to take further for the user.
I want to add up to that answer. Like collision diagram actually is one of the separate database in Connecticut Crash Data Repository. But because that data is too large in size, because collision diagram are all kind of pictures, figures. So we have stored them in different database. But for these projects, we mainly focus on the text data instead of the collision diagram. But as Jingwei mentioned, the collision diagram, it can definitely be kind of integrated into the large language model, and which makes this a future work as well.
It's great to think about the holistic, what other challenges are out there and what we can automate. It'd be really fascinating. So I'm going to jump to another question and we'll jump back to that one previously. So once live, do you plan to have periodic result validation? So you talked about validation a little bit already, but this person states that the system could receive hundreds of queries and the risk of producing wrong results that end up in the press or other broadcasts are high. So how do you think you could handle that, or what would be the plan with periodic result validation as you go live?
Yes. So recently there are a lot of researchers on model confidence levels about large language models. That is about how confident the large language model is in responding to their corrections. In a correction that large language model gets wrong, the funny part is that it will get it wrong differently every time we query it. Therefore, since we log users' query because we want to know what public actually caring about. When we see a lot of events with similar query with different result, we know that the result might not be correct. Then therefore, there are two options. First of all, we do in-context learning, giving the large language model more examples, the correct examples of how to handle those questions. Second option is for us to fine-tune the model if we do have access to OpenAI training, or we can just use a local model, as Llama 3.3 is super powerful right now. It's powerful enough to handle this project.
And then pivoting back to that question from earlier regarding AI hallucinations. So a little bit of context. So for example, a user asks for some data that the database doesn't have, or it's not complete, or for the town or region that doesn't exist. So this person's basically saying a hallucination is very common, with LLMs tending to provide a response, even if they have to make up a response. So maybe if that provides a little bit more context, and maybe you share a little bit.
Yeah. Okay. So in this mechanism, that problem does exist. That's a great part of this mechanism. So first of all, the first example I've showed you is asking for the cities. And in the database, there isn't a city. There are only town names. And if such, you ask for a city's name that does exist. Let's say Boston. Boston is not in there. In that case, when the large language model generates a data analysis code, looking for a specific keyword, Boston, in the town name column, then there isn't any result going to return back. Therefore, in that case, you will get an empty data frame, and we will say that the thing you're looking for doesn't exist. Please check your query, something like that.
Yeah, it's good to hear that those validations are in place. Really quick, how is this program faring, or how are you working with maybe Connecticut DOT? Have you worked with them at all, or talked to them in terms of they're referring to data being compromised as this application is being deployed? Are you working with the DOT in that capacity?
I can help answer this question. I think probably this audience comes from City DOT. Yes, we did, and the short answer is yes. So the data is actually directly come from the Connecticut Crash Data Repository, which is a public available data. So we didn't make any of our own data, and anything to train the model in this study is just from the public data available from the CTCDR. So I think the audience should be familiar with that. On the second part, we did talk about some of the potential application and even the deployment with CTDOT, and we do have some conversation with the research unit occurred in the past, and we are still in some of the good conversation right now. So hopefully we can bring that conversation onto the table so that we can probably talk about more opportunities and even the future improvement and deployment this kind of system to the CTCDR, and which can serve CTDOT as a platform they can use to query and download the data, crash data from the CTCDR. Hope I answer your question, but if you are interested in this type of program, you can feel free to reach out to me. So I think we can have a lot of discussion on the Connecticut Crash data and also how we can best serve your needs from CTDOT's perspective.
If anyone in the audience needs help connecting with these speakers, feel free to reach out to us. We're happy to provide the contact info for all of that, and get you in touch with them. So two last quick ones. How much metadata is required to take crash data and apply your tool to it? This metadata may help the model understand where data are located and what they mean. For instance, like the injury scale of injury severities, etc.
In realistic speaking, it doesn't take much. 3 rows, like a tiny little bit of it, will let it understand it already, because the major structure of the data analysis are actually relying on the column names instead of the row values. If you think about the actual process of Excel, of an Excel document, your boss asks you, okay, what is our total sale in January? You will go to the month column, January, and look at the month column and look for any value that matches January. You are not going to iterate through each row, as it is not efficient, and the program will not do it. The program will try to analysis on the column as much as possible. And if there's a specific reason that it has to look at the row, it very likely won't do it. Because for example, you ask for a specific crash with the crash ID 100016, and since you touched the crash ID column, which we prohibited, we don't allow it for now, and we touch the column, you will get the message that says you are violating our rules. But we don't have, for most of the data analysis fractions, you won't really touch a specific row.
Awesome. And then last one, this refers to the prompt setup that you have. So is there any reason for not allowing more of a conversational approach like the ChatGPT model where you're having a conversation rather than just the single question you're allowing?
For the actual development, we will actually allow a conversation. However, even you see that there was only one text bar for me to put input in there, it actually holds the conversation history with the browser cookies. Like each session has its own memory. But for now, since we are researching on how to approach this structure and to ensure its reliability, we haven't we think about the threading, about how to hold each conversation, but we didn't implement it for now, since it's not a major concern for now.
Awesome. Thank you so much to everyone for attending, and even thanks more to the presenters here today. It's a wonderful presentation, a boatload of questions. If you have any more questions that you'd like to relay to these presenters, feel free. We'll make sure you get their contact information moving forward. But that will conclude this month's NEUTC webinar, and we look forward to seeing you all next time. Thank you so much.